Hi students, welcome to Alpha C learning program Mathematics. Now in previous session we have done some problems basing on two tangents drawn from a point outside to a parabola and concept of common tangents. Now let us observe students properties of tangents. Before entering into the concept of properties of tangents, let us have a glance on what about point of intersection of two tangents drawn at 2 points t1 comma t2. Suppose here this is the standard curve I am taking, again y square equal to 4ax. Okay, the standard equation I am taking, y square is 4ax. And now this is a tangent drawn at the point t1. Okay, so tangent drawn at the point t1, that is at1 square comma 2at1. And next one, this is a tangent drawn at the point t2, that is at2 square comma 2at2. Now our interest is here, what is this point of intersection? So we require here point of intersection of the two tangents directly. Of course you know what is equation of tangent at t1. Okay, equation of tangent at t1. What is this equation of tangent at t1? To the standard form. It is nothing but yt1 is equal to x plus at1 square. Okay students, and next one, the tangent at t2. Okay, at t2, this is yt2 equal to x plus at2 square to the same parabola. Okay, now we are subtracting here, we want here the coordinates of point of intersection, that means we want to solve these two equations. Then y into t1 minus t2 equal to a into t1 square minus t2 square. So t1 minus t2 into t1 plus t2. As t1 is not equal to t2 because we have taken these two are different points, therefore we can cancel this. Implies what is our y value? It is a into t1 plus t2, right? And once you got y value is this one, then what about x coordinate? You can substitute again in first equation or second equation or in parabola equation. So I am taking suppose first equation, yt1 is x plus at1 square, right? And now x is our requirement, y already you got here. So a into t1 plus t2 and into t1 minus at1 square is equal to our x value. So at1 square here students, that will be cancelled here with this value, and the leftover thing is here how much? It is at2 square, t1 t2. Okay, therefore here the value is at1 t2 is equal to x. So finally what is our point of intersection of the two tangents? It is nothing but here at1 t2 comma a into t1 plus t2. One of the important formulae, because we are going to now prove some properties of tangents which are very useful in our problems. Therefore whenever you take this kind of standard form, y square is 4ax, then the formula is at1 t2 comma a into t1 plus t2. So students, this is formula for what here? Point of intersection of two tangents. So let us write here the point of intersection of two tangents drawn to. Okay, so point of intersection of two tangents drawn to the parabola y square equal to 4ax. Two tangents drawn to the parabola y square equal to 4ax at what points here? At t1 comma t2. Okay, at t1 comma t2. The meaning is here what? At at1 square comma 2at1, and this is at at2 square comma 2at2 is what is our formula? It is nothing but at1 t2 comma a into t1 plus t2. Okay, this formula applicable only to this standard form. Point of intersection of two tangents drawn to the parabola at t1 comma t2 is this formula. Okay students, now let us observe properties of tangents one by one. Very important students, these properties. In parabola some theory concept is there, and you have observed already in focal chord also we have discussed about some properties, whereas in tangents they are not less, they are some more are there than focal chord. Okay, now observe the first one. Suppose tangents are drawn at the ends of focal chord. Okay, at the ends of focal chord implies they are drawn at the ends of a chord which is passing through focus. Then they intersect on exactly directrix. Not only directrix, extra also there. What is the extra concept? At right angle. Okay, suppose you are taking here chord value, that means here two tangents we are taking. Let us make use of here standard form y square is 4ax. Students, whatever properties I am writing here, understand I never mention here the equation of parabola. Okay, so this one is if tangents are drawn at the ends of focal chord of a parabola, you write here of a parabola, then they intersect on directrix at right angle. Okay, so this one is parabola, just we are mentioning, as we are mentioning just parabola, it can be applicable to any kind, horizontal, vertical or oblique parabola. Okay, so now let us take here equation of parabola as y square is 4ax, only for proof. Okay, and next one, focal chord, suppose you are taking, you can start the proof even with end points, you can directly take latus rectum also. Now I am taking this one here, this focal chord I am taking 80 square 280 is one end I am taking. Okay, or else let us take 81 square 281, and this is our focus a comma 0. And now here this is the other end of focal chord a-t2 square comma 2a-t2. Hope all of you remember about the focal chord concept. What is focal chord concept here? T1, T2 is -1. Okay, therefore PSQ is focal chord, implies our condition is nothing but how much? T1, T2 is -1. Okay, and this is to our standard parabola. Or directly you can write a by T1 square comma -2a by T1. Now they are telling if a tangent is drawn at P, okay, at P a tangent is drawn, and again at Q another tangent is drawn, right, at Q another tangent is drawn. Now these two are intersecting. Just now we have observed the formula of point of intersection of tangents. So what is this formula here? A T1 T2 comma A into T1 plus T2. Okay, so this is the formula for point of intersection of tangents. Now here suppose I am taking this as R. Now students, as this is the focal chord, therefore the advantage is T1 T2 is how much here? -1. Therefore this is minus a comma whatever the ordinate value, but abscissa you got how much here? -a. Now once abscissa is -a, observe to this parabola what is our directrix equation? The directrix equation is nothing but x equal to -a. That implies, you can observe clearly students, this point is exactly on directrix. Implies the two tangents, whatever they are intersecting, from where they are drawn at the points, that means for ends of focal chord, then this is nothing but exactly those two are intersecting on directrix. So this line is what here students? This line is our directrix. And what is the directrix equation actually? Which is nothing but x is equal to -a. Okay, a line parallel to y-axis and x is -a. Now once you got this one more point also here they mentioned. What is the point? They intersect at right angle. Okay, then how we can decide exactly they are at right angle? Now what is slope of this tangent? Okay, what is slope of tangent here? So slope of tangent, all of you know, it is the equation is yt1 is, understand, x plus at1 square. So slope of tangent at t, understand, slope of tangent at t is nothing but how much students? It is 1 by t. Therefore here you can make use of simply that kind of concept. So let us write here equation of tangent yt is x plus at square, then slope of tangent is nothing but 1 by t. Therefore I am taking here slope of tangent drawn at t1, okay, at t1. So what is this value here? Is 1 by t1, okay. Similarly, slope of tangent at t2, what is at t2? It is nothing but 1 by t2. Now what is product of these two slopes? Product of slopes is equal to, so product of these slopes equal to how much it is? 1 by T1 and into 1 by T2. But what is our T1 T2 students here? It is -1 because of what reason? Because T1 and T2 are exactly ends of here focal chord, and in that way you got here -1. Since T1 T2 is -1, as focal chord we have taken, okay. So because of focal chord condition you got T1 T2 is -1, hence you got this condition. So here students you can observe clearly 2 points. One specific point is here, if tangents are drawn at the ends of focal chord, okay, at the ends of focal chord, one important thing, and then they intersect on directrix, okay, on directrix, just not normally but extra condition, that is at right angle, okay. So these are 3 important concepts. So to any parabola, if tangents are drawn at the ends of focal chord, okay, then they intersect on directrix at right angle. Got all of you? One of the important concepts this one. And students, whatever concepts you are learning here, these will be again applicable in some other chapters. They link these problems, okay, with again parabola, ellipse, hyperbola, even in complex numbers also they can link. So concept is very, very important. Now let us observe students here the second one. The second one is nothing but the ratio of area of triangle, okay, the ratio of area of triangles. What are those triangles here? Formed by, first one is any 3 points on a parabola to the area of triangle formed by, okay, the tangents drawn at these 3 points, okay, at these 3 points. First one is points on parabola. For example, I am showing here, first one is here, if this is the parabola students, and once here this is one point of contact, suppose you take P, and this is the other one Q, and this is suppose here R, okay. So these are 3 points, and let us take here, suppose this point is 81 square comma 281, and this is 82 square comma 282, and this one is 83 square comma 283, okay. Now here also they did not mention anywhere the parabola is only y square is 4ax. So whatever properties students I started here, these are meaningful for any kind of parabola. So for proofs only we are taking the help of standard form. So what is this equation here? Y square is 4ax, hence we have taken 3 points of contact like this. And now if I join these 3 points, okay, if you join these 3 points you are going to get a triangle. Now this area we can obtain, and they said here this area suppose it is delta 1, understand. So the ratio of area of triangle formed by any 3 points on parabola. So 3 points we have taken, and now we are going to find this area. Suppose let us take it as delta 1, understand. Next one, next what they are telling here, to the area, the ratio is with what here? To the area of triangle formed by tangents drawn at these 3 points, at, understand, at these 3 points. That means if I am taking here one tangent drawn at P, this is a tangent at P, okay, and next one, this is our tangent at Q, okay students, tangent at Q, and next this one is tangent at R. So these are the tangents we have taken. This is tangent at R and this is tangent at Q. Now what about here? This area also they are asking, okay. So one is area of triangle formed by the 3 points on the parabola, and the other one they are asking about area of triangle formed by 3 tangents which are drawn at the same points, whatever you have taken here, at those points only, not one is here, one is here, not like that, at these 3 points, okay. So observe here, at these 3 points, then they are asking about the ratio of those areas. Suppose I am taking this as here delta 2, then they are telling delta 1 divided by delta 2 is nothing but 2:1 ratio. Now let us prove here, very easy only, just the concept of nothing but determinants. Okay students, so first of all, what is area of triangle here formed by the 3 points on parabola? So what are the 3 points on parabola? Let us take it as delta 1. Okay, delta 1 be here area of triangle. Okay students, formed by area of triangle formed by 3 points on parabola. That is P of 81 square comma 281, and next Q of 82 square comma 282, and R of 83 square comma 283. Okay students, so now we are finding these values. So these are our 3 points on parabola. Standard form y square is 4ax we are taking, understand, on the parabola. Now what is our formula when 3 points are given? The standard form of area, many concepts are there. Now I am using this one. So delta 1 is nothing but half of, okay, half of 81 square 281 1, and this is 82 square 282, and this is 1. Again 83 square 283, it is 1. Okay, so this is our area triangle. Now from first column let us take A out, and from second column let us take 2A out. Then this is half A into 2A. This is from first column, this is from second column. Then you got T1 square, T2 square, T3 square. Okay, and this is T1, T2, T3, and this one is 1 1 1. Okay students, in this way you got. Now you might have remembered the concept of determinant, the formula 1a square, 1b b square, 1c c square is a minus b into b minus c into c minus a. So here if you interchange these two values, okay, if you interchange these two columns, then the value of determinant changes by sign. Anyhow, we are having here mod symbol. Okay, area means you are using here mod symbol, so final answer it will be positive only. Therefore I am taking here 2 and 2 cancel here. Finally, what is this value students? So by using our known formula, now I am writing this value directly. It is nothing but a square. Okay, it is a square, and into, if you interchange these two values, then we can obtain the formula as nothing but here it is nothing but a square into a minus b, okay, into b minus c, and into c minus a. So this is our formula. Okay students, so now this is our area value which we have obtained just by taking points on parabola. Okay, points on parabola. Sometimes they may ask here objective questions not in terms of T1, T2, T3 but in terms of x1, y1. Okay, objective question they may ask here, what is area of triangle formed by any 3 points x1, y1, x2, y2, x3, y3 on the parabola y square equal to 4ax. So if you can remember this formula, so just a small deduction here itself I am doing students. A small deduction here itself I am doing, that is nothing but on parabola, suppose you are taking here points x1, y1, okay, x2, y2, and next x3, y3. 3 points are taken on a parabola, y square is 4ax. Then they will ask about what is the area of triangle formed by these 3 points. Okay, then up to here if you can remember this formula, because easy only a square into this entire thing, then you can make use of here this y1 is how much actually 2a t1. That implies t1 is how much here y1 divided by 2a. Similarly t2 equal to y2 divided by 2a. Similarly t3 is how much here y3 divided by 2a. Okay, then those values if you substitute here, what is your area in terms of here x1, y1, x2, y2, x3, y3. It is nothing but a square into how much here t1 means y1 by 2a, okay, minus it is y2 divided by 2a. Like this if you write here also the other three parts also if you write, then what is the value students here you can get? This is y2 by 2a minus y3 by 2a, okay, and into y3 by 2a minus y1 divided by 2a. So just you can convert in the form of here x1 y1 etc. Then here 2a, that means you got here a square divided by 8a cube. Understand? 2a into 2a into 2a, and this is mod of y1 minus y2 into y2 minus y3 and into y3 minus y1, okay. Then if I cancel this value a square here, so this is another kind of formula for area of triangle formed by any 3 points x1 y1 x2 y2 x3 y3 on the parabola y square equal to 4ax. So this also here students you can make use. Understood? So now we have done here area of triangle formed by 3 points on parabola. Chalo, next one is what here? Area of triangle formed by 3 tangents, okay, 3 tangents drawn exactly at these 3 points. Then only we can discuss about the ratio, okay, not any other 3 points exactly. Wherever you have taken the triangle, at those points only, those vertices only you have to take now tangents, okay. So now here this is our parabola, y square is 4ax students. Now you are taking here tangent, okay, at t1. So this one is here t1, that implies a t1 square to a t1, okay. And next this is suppose another tangent drawn at a t2 square to a t2, okay. And next one another tangent here I am taking, so this one is nothing but a t3 square to a t3, okay students. So now here this is the point P and this one is Q and this is our R, right. And now we require this triangle, okay, this area we require. Now for this area clearly you can observe, suppose if I am taking this is point of intersection is A. How you got this A value? This A value is nothing but point of intersection of tangents drawn at T1 and at T3, okay, drawn at T1 and at T3. Therefore what is this value here? It is a T1 T3 comma a into T1 plus T3, right. So this is the value. And next one, you observe this point of intersection, suppose if I take B, okay, then this tangent is drawn at T1, this is at T1 and this one is at T2, okay students, at T2 and this is at T1. Therefore B coordinates are a T1 T2 comma a into T1 plus T2, right. These are drawn at T1 and this is at T2. And next what about here? This is C. If I take C, then C coordinates tangent drawn at T3, okay, and drawn at T2. Therefore C coordinates nothing but here a T2 T3 and comma a into how much it is? T2 plus T3, okay. So now you got clearly by taking the concept of point of intersection of tangents, the 3 coordinates A, B, C, which are nothing but the vertices of triangle formed by tangents drawn at the points of contact P, Q, R, okay. Now what about this area, okay. This area is nothing but how much students? It is, let us take delta 2, okay. Let us take delta 2, it is half of, how much we write here? A T1 T2, any values you can write because mod is there anyhow. So a T1 T2, a into T1 plus T2 and this is 1, okay. And next one a T2 T3 and this is a into T2 plus T3, this is again 1 and this is a T3 T1 and it is a into T3 plus T1, then again this is here 1. Understood all of you? So in this way you can obtain here area formed by the 3 tangents. Then again evaluation is just like the concept of determinants. So from the first column students, how much we can take common? From first column you can take here A as common and from second column take another a common, thereby a square value will come outside. So this is equal to a square divided by 2, okay, a square by 2, and it is determinant inside. What are values here you are having? T1, T2, and it is nothing but T1 plus T2, and this is again 1. After that here T2, T3, okay, and this is T2 plus T3, and this is 1, and this is T3, T1, T3 plus T1, and this is here 1. So we have taken a from this column and from this column, thereby you got a square by 2 is here, this is the value. And you know the simplification method, once in a column all are ones, you can make use of simply R2 as R2 minus R1 and R3 as here R3 minus R2 you can write, or R1 you can write. Anyways you can use, okay, R3 minus R2 or R3 minus R1. Then you can get students here simply this determinant value is nothing but mod of again T1 minus T2 into T2 minus T3 and into it is T3 minus T1, okay. So this kind of determinant you can obtain from the second value. So this is our delta 2. So what is our delta 1? You don't have this denominator, and now you got delta 2, you are having this denominator. Therefore delta 1 divided by delta 2 is nothing but how much here? 2 divided by 1, okay. So delta 1 we have observed students, it is just only a square you got there, okay, a square you got. So delta 1 is nothing but a square into you got T1 minus T2 into T2 minus T3 into how much it is? T3 minus T1, okay. So this is the value of delta 1 you got, and this is delta 2. Therefore delta 1 divided by delta 2 is nothing but 1 by 1 by 2 implies 2 divided by 1. Hence what about the ratios here? It is nothing but 2:1. Understood students? So these are one of the important concepts. Then they ask here the same question, what about here ratio of area of triangles formed by points on parabola and tangents drawn at those points to the parabola. Then what about that value? Suppose a parabola given as x square minus 4xy plus 4y square minus x plus some k value is 0. Okay, what about areas, that is ratio of areas of triangles formed by the entire story, again they repeat. Then not necessarily you have to go for what about the points etc, everything, just you make use of here the concept. Simply the answer is how much here? 2:1, okay. So any kind of parabola students you can make use of this kind of concept. One is formed by points of contact, the other time area is with tangents, okay. Now let's have a glance on third property students. Till now we have observed two properties. This one is the third one. The locus of foot of perpendicular drawn from, okay, foot of perpendicular drawn from focus S on any tangent to a parabola is nothing but tangent at vertex, okay. So we can use here feet of perpendicular also, locus of feet of perpendicular drawn from focus S on any tangent, okay, to a parabola. Again we generalized here, not only for the standard parabola, it can be for any kind of parabola. Again as usual for proof students, we are taking the parabola y square equal to 4ax, okay, y square is 4ax we are taking, and this one is tangent drawn to the parabola at at1 square comma 2at1. So this is at square comma 2at we are taking tangent, and next one is here focus we are taking as our known formula a comma 0. Now if you take here tangent from, this is tangent we have taken, and here if you take perpendicular from focus onto this tangent, then this one is nothing but exactly where this foot of perpendicular is, exactly at tangent at vertex, okay. And suppose if you consider students, again suppose another tangent I am taking here, okay, this is another tangent, and next if you are taking here foot of perpendicular from focus, so if it is 90 degrees, Then this point also again on tangent at vertex. You know clearly this is our tangent at vertex. So from focus, whatever foot of perpendicular you have taken onto these tangents, okay, if you join those points, they are exactly on tangent at vertex. And one easy example you can see here, this is exactly at vertex from focus through the vertex. This is our vertex 0 0, okay. So this is the point A, 0 comma 0 is vertex, and this is our foot of perpendicular which is exactly on tangent at vertex. So not only those, whatever perpendicular you are taking from focus on any tangent, again if you take a tangent here, okay, a tangent here, and again if you take foot of perpendicular, then this foot will be exactly on this one, okay. So like this here you can find here from focus, it is fixed point from focus, the foot of perpendicular drawn from it onto any tangent, okay, onto any tangent, always they lie on what here, tangent at vertex. Then how we can do this proof? Very simple only. What is our equation of here? Tangent drawn at t, okay, equation of tangent drawn at t. So that value we can consider here. So if this is parabola, this is our tangent at vertex now, and now suppose this is the point A of 80 square comma 280, or P let us take 80 square 280, okay. And now we have taken a tangent here like this, this is our tangent, and next the focus, from focus if you take, and this one is our perpendicular they are telling. So this is our S of A comma 0, and this equation you know it is yt equal to how much, x plus 80 square, and this is what here equation of tangent at vertex is y axis, that is x is 0. So when x is 0 students, what about here coordinates, y equal to 80, okay. So at x is 0 you can observe yt equal to how much here, 80 square, that implies y equal to 80. Therefore this point if I take suppose q, okay, then this is coordinates are 0 comma 80, understand. So this is x0 we substituted, and thereby you got y equal to how much, yt is 80 square, so 0 comma 80, and this is the other value. Let's have glance on slopes, okay. Slopes you can use, or you can find foot of perpendicular, anyways you can use, but I am taking here slope. So what about here PQ slope? What is PQ slope actually? It is 280 minus 80 divided by 80 square. So one of the methods I am doing directly by taking slopes, okay. So this slope all of you know it is nothing but how much, it is clearly 1 by t, okay. Slope of tangent it is 1 by t. Now what about this slope here? If you observe this slope, it is 80 divided by minus a, that implies it is minus t, implies product is how much here exactly, minus 1, okay. So slope of tangent at here how much here, tangent at t, this slope is nothing but how much, it is equal to 1 by t, right. And this is slope of which one also, PQ also, which is slope of PQ also, okay, right. And now what about here slope of the line joining S and Q, okay. So slope of line joining S comma Q, and this is equal to 80 minus 0 divided by denominator minus a, therefore this is minus t, and you can observe clearly these two are at right angle, implies where is the point of intersection, it is exactly on tangent at vertex. In other way also you can do the same proof. What is in the other way? Let us take here foot of perpendicular as x1 comma y1, okay. Instead of in this way you can do exactly the theorem, that is let us take here the point of intersection we don't know in the beginning, so let us take it as here x1 comma y1. So let x1 comma y1 be foot of perpendicular, okay students. And once you know this is foot of perpendicular, then we know the formula. what is our formula? H minus x1 divided by a equal to that kind of formula now I am using. So this is your x1 comma y1, okay, and this one is here. What is the other point here? This is hk. So I am writing, or any form you can write here, that is our formula. If I write x1 minus a divided by the x coefficient is here 1 equal to, what is the next value here we are having? It is y1 minus 0, okay, divided by the equation is here yt is x plus at square, implies it is nothing but x minus yt plus at square is 0, okay. So now this is our standard equation, and divided by here minus t equal to this side minus of, okay, minus of, you have to substitute a plus at square, and divided by what is denominator? The denominator is 1 plus how much? T square. So now finally you got here from the foot of perpendicular formula, x1 minus a is y1 by minus t equal to, this side you got here minus a into 1 plus t square divided by 1 plus t square. So these two values cancel. Now if I equate these two values, students, x1 minus a equal to how much? Minus a, implies x1 is equal to 0. Whatever the y1 value, but x1 you got how much here? 0. x1 is 0 means this is exactly what actually y-axis. Y-axis to this parabola is nothing but what? Tangent vertex, implies locus of q, that is locus of the points x1 y1 is nothing but what here? It is y-axis, and in this parabola this y-axis is, which is here, it is nothing but tangent vertex. Therefore what is our conclusions finally here? The locus of feet of perpendiculars drawn from focus on any tangent to a parabola is nothing but tangent vertex. And the same concept, students, even it come in ellipse and hyperbola also. There the name is different. There we call it as auxiliary circle, whereas here it is tangent vertex, but concept will be coming once again, okay.